Welcome to this Open Security Summit session in May 2021. I'm actually presenting this one, and again, let's have a conversation, a debate about it. But this is about something that I'm very passionate at the moment. Well, I feel I've always been very passionate about this, but I never really connected a lot of the dots that I have in the last year or so. So this is about this idea of positive security models and rebuilding it to a known good state. And I'm kind of going to use a lot of I'm going to start with some examples from where I work right now, because we are doing this, but I want to expand this. I want to kind of look into the future, and also what we could do, and what I actually hope a lot of other people do in the industry, because the idea of a positive security model, which is instead of looking for bad, you kind of go into a good state, right? You go into a state where we basically know what good looks like, and it's kind of one of those things where I found that if you look at security, a lot of the best patterns in security have that. Even something as simple as, or not simple, but a key concept of don't mix code and data, right? Which is the key for preventing buffer overflows, which goes down 20, 30 years. Again, it's all about making sure that you understand where your data is. You understand what good looks like, what bad looks like. Sorry, not what bad looks like. What you want things to be, and you make sure that they behave in that way. Like a variable is supposed to be here, so I'm only going to make sure that that's the space that it has. So one of the things that we're going to cover here is a lot of these areas of the known good pattern can be applied. So we're going to talk. It's kind of a wide range of topics. We're going to cover from source code to files with business context to DevSecOps, config, cloud environments, network traffic, some machine learning at the end, just for good measure. And I really want to explore these particular areas. Now, this is actually one of the things that I've created from one of the Glasswall sort of longer term review, where you can kind of see that Glasswall does a process also operates in a process called a CDR, which is content disarmament reconstruction, which I'll go in more details in a bit. But fundamentally, we create safe files and email attachments, right? And other things that you can have from a business file point of view. But my vision already for the company is that we should be looking at other things in the future, right? And you go from just a protect to even detect and then respond, and eventually you want this pattern to be everywhere, right? And again, I'm not saying that Glasswall is going to do all of this, but I think that we should be able to consume a lot of this and help to drive a lot of this stuff. And also there's a lot of technology and processes and capabilities that you can develop over here that we will get to use over there. So let's look at CDR for files and email attachments. So CDR is a content disarmament reconstruction. It's actually quite a mature industry, right now. There's a lot of players. There's a good sort of level of innovation, and it's all about this idea of creating safe files where you go into a good sort of standard. You basically take a original file, you look at the structure that it has, and then you rewrite it into a good sort of model. And I'll go into details in just a second. And Gardner actually currently has it here on the peak of inflated expectations, and he kind of predicts that it will reach sort of mass usage in a couple of years, right? So there's a lot of good market players here. Here they are. Glasswall is one of them, but there's some really good players in this that all innovating, all kind of moving technology forward, which is really cool, right? Because I have to say that from my experience until I joined the company, I really didn't trust this technology, right? It wasn't something on my radar, and I feel it really needs to start to be. So fundamentally, the way most of some of the engines work, right? And of course, each has its own particularities, but fundamentally, you got files have three main layers, right? There's a structure, there's a functional layer, and there's the content layer. And the logic here, especially from a business point of view, is you leave the visual content layer the same. So the content is the same, the pixel structure is the same. So they look just like the same file, but we basically protect it at the structure level to make sure that the file actually matches a standard. And we basically then have ability to say, what do you want to do about macros or JavaScript or embedded files or URLs or links, etc., right? Or metadata, things that from a policy point of view, you might want to not basically persist when you copy to the other side. So this is where the known good, the positive model goes. So this is not an AV where you're looking for a signature or a behavior-driven sort of, AI or ML engine or kind of a pattern-based sort of, technology, or even a sandbox where you detonate things and see what happens, right? This is not about looking for bad. This is about knowing what good looks like, and then you rewrite into that, model, right? And we kind of managed to get it to work. So fundamentally, in this case, you have unsafe file in, safe file out, right? And so in this case, that we have other workflows, but fundamentally that's the pattern, right? Where in what's really cool about this is that the user does not have to care about clicking on an email, right? Or opening up an attachment or opening up a file, downloading a file, because the files have been, are in a safe state. So from a kind of technology point of view, the idea here is that you take a file, right, and you go from original to generated, and the key logic here is that you need to basically understand the structure of the file. So the way, for example, we do is we actually map a whole of dynamic data structures, which we basically then apply a bunch of rules, and we create these engines that allows us to process a file from one to B. And this is where things get complex very fast, because, for example, if you look at specifications on the Office, right, you can see that just the specifications for Office XML or the binary or PowerPoint or Word, it's like 5,000 pages, it's 1,000 pages, right? So, and of those, you have to extract a whole number of structures so you can then rebuild it. And then, you have to apply a whole bunch of structure rules and validation rules. So that's how you go into a known good state. So the pattern, it's kind of also very similar to static analysis, right? So the pattern here is that you're basically going from original content. You go from an original sort of data set, and then you basically parse it, and you then have an object representation in memory, and then you do something to it. And in some cases, you could just analyze it and come up with an answer. But the idea here is to actually rewrite it. So we rewrite something which is like the original, but in a good state. So it doesn't have stuff that shouldn't be there. And you can apply a whole bunch of rules and validations into it. And there's actually some really good, actually, I didn't put the link here, but I'll show quickly, because actually the Open Security Summit, we did some really cool sessions on it, which is this internet, inspection and sanitization guides, where it's really cool to be able to go here, right? And actually use an Open Security Summit session for this. So actually, where's the archive? Sorry, I was looking for the GitHub repo, but yeah, I could just show the file, right? So this is basically a whole set of files published by the NSA in this case, who go into very detail about the structure of a file. And they basically give information about the file, what you're supposed to do with it, the structure. So it basically covers, for example, what exists on each of these, and then they basically they then provide a huge amount of information about what you do with that. Do you validate, do you replace, do you remove, etc. So this is really cool. So this is basically a sort of a meta, almost like mapping of what do you do with a document to make it safe, right? And it's complex, but it's very important, because this allows us to have a very good understanding of what does good look like. And these documents provide that, and they are really, really cool, right? In what's it called? In this way to do it. And I'll show you a good place to find it. If you actually go to the GitHub for Open Security Summit, and you go and you look for ISG, we actually started this process of mapping a lot of them here. So you can see that for a lot of these formats, you actually have an ISG that will tell you what to look for, what to map, what does kind of good looks like for each of these documents. And that's super important. And that's something that, when we talk about later on about the other positive models and going into known goods, it's very important that we we then, take all of that into account, into actually how all of that is happening. So, for reference, the way kind of, again, just our engine works quickly is we take one of those pages from the specs. You can see that literally this is where the action is. This is where it tells you what each byte means in the structure. So this is actually the byte structure. This is actually the information about what each is supposed to be. We convert that into these kind of structures. So this is basically where you go from raw binary to a memory representation of that already starts to understand, what things are. So you can see CMT there is going to be this particular reference. FCI is going to be here, that bit's going to be further down. So, and then and this guy has a range. So it's super important to have this so that we can then go to the next level, which is we can then start to create this binary definition language. So as we write the rules, right, we can then, come up with ways to then define, okay, here's my rule, here's what I want to do, here's what should be there, this, you can ignore, this should be a requirement, this guy should map the other thing, etc. So this is basically the rules that you apply. So when you write the known good structure, that's what it looks like. And that's sort of, again, that's an example of, a structure for binary of how the validation actually works. And you can see it has to be this range, it has to be there, right? So this is where, eventually it becomes, the validation of this. Now, by the way, if any questions so far, feel free to put them in the chat or just ask away on this. So there's a lot of interesting metrics here. So we could see that today, like the CDR world already shows that rewriting into a known good works, right? It works at scale, is highly effective. It's been used in some of the most challenging environments in a planet. It's been used by customers who have a very high demand for security. And again, it's a very solid pattern. But even then, one of the things that's interesting here when I was thinking about this process is even the definition of known good might actually change over time. So even although, for example, we go by the ISG, or we go by a particular interpretation, right? You might have cases where some things changes. You might have exploits that, for example, manipulate things even on a design document, right? There have been cases where vulnerabilities appeared. It was not even a parser problem. It was just that the design was actually vulnerable, right? That allowed some execution or allow some behavior to exist. And I feel that it's very interesting to even think about, as we evolve this, that our own definition of safe and known goods will actually be sometimes modified, maybe based on events, or maybe by new exploitation techniques, or an evolution of some of the attackers. What's cool about it is that we now have a chance to deal with it, because we have one place that we can apply rules that then can be enforced everywhere, which is actually super powerful. So that was files, right? So the current state is that you start with files, you start with Office, you start with PDF, you start with GIFs, etc., right? Then there's a next level of world, which gets very interesting, but also very much more, complex in a way, which is, can you start to apply the same principle to HTML and JavaScript, right? So can we apply the same principle of rewriting known good into HTML, which is one of those sort of massive problems that we have, which is sometimes, a lot of websites and a lot of development teams and a lot of frameworks produce, for example, non-compliant HTML, or produce a lot of stuff that shouldn't be there, or allow a lot of things to be modified that they shouldn't be modified. And even some of the things of, for example, trying to do content security policies and a lot of other stuff, it's great. But for example, like, why can't we start to whitelist and know that specific models do some of the things really well, and they shouldn't really change? And maybe when they change, we should understand much better what has changed in those things. So I really like this idea of starting to even be able to fix a lot of the issues that we have sometimes on websites by rewriting HTML into a known good state. And what this means, and this is where it gets very interesting very fast, it means in some ways you're going to be limiting sometimes the technologies and the frameworks used in an application, which which from a security point of view has a lot of advantages, right? It's not because you can that you should mix, frameworks and jQuery and React and this and that on the same page, right? If you look at some of the way the ads work, right, they completely do things that maybe shouldn't be done. So I think there's a lot of very powerful, there's a lot of power here on being able to start to rewrite HTML to a known good state and then find a good way to read what that state looks like, for example, from a developer or from a framework, right? And that's where this gets more interesting, because I think the definition of known goods in a file like PDF won't change very much, right, in context, where a definition of known good in HTML is actually going to be much more dynamic. But it doesn't mean that it's not a lot more valuable to do that. Even on, content security policies, right? You might actually have a way that you rewrite it so that you inject all the content security policies in the right place with the right settings, with the right configuration, and that allows that thing to scale. So I think there's going to be some very interesting cases where and I talk a bit later on the source code, where this has a huge amount of implications, but it also has a huge amount of potential for allow us to create very secure environments, right? A good example is actually Hugo, right? If you look at Hugo, we actually use an Open Security Summit or the kind of the static site generators, you can actually argue that those websites, those structures rebuild the files into a known good state. It's a static page. It doesn't change. It's always the same. Well, that is pretty good compared sometimes to some dynamic content who can, yes, can change a bit, but also can cause a lot of vulnerabilities, can cause a lot of injection capabilities, right? So I think that's really good. And then the JavaScript, of course, now takes into account that there's a lot of JavaScript that sometimes we don't understand how it works, right? So again, the JavaScript here is probably going to be the same level of complexity as when we talk about source code a bit later, where it's about actually, can we start to force or understand known good patterns, again, on JavaScript or even on source code, which I think is going to be a super powerful topic and capability. Now, the other one is APIs, right? So basically, we have lots of APIs left, right, and center, and in a way, we could actually be rewriting the content, from one API to the other, right? You can actually do a huge amount of security if you start to say, well, I know what this API can hold. I know what good looks like to this API. I can make sure that the data from here doesn't enrich it, or even more, or the other way around. You could put something in front of an API to make sure that only only good stuff hits that API. And it could be to make sure that everything is authenticated, make sure that everything has validated a particular standard. Could be that even certain methods that shouldn't be called in certain sequence are not called. So I think, there's a lot of interesting stuff that you can put logic right in here, that some of it can exist in the application, or even better, you can read the stuff from the application and enforce it, which is why we start to also cross over to maybe the next generation of WAFs, which could also be doing a lot of this. So again, this idea that can we rewrite API traffic into a known good state? And there's one underlying topic that you should think of across everything here, which is the more we know what good looks like, the easier it is to detect bugs, but also malicious activity and calls that shouldn't exist. So for example, if I know that this API endpoint should only call that API endpoint, and you either have a way to enforce it or monitor it, or even at least get a sense of what that looks like. If another service makes a call to that endpoint, that is either a bug, something that needs to be updated, or more interesting, an attack that you now have early access to, right? You have early warning of what's happening. Because the way I look at this, the security model that scales is not based on fixing everything, having no vulnerabilities, having systems that are insanely secure, because sometimes that is not even possible. It's making sure that you have a model that depends on the attacker making a mistake, right? And the attackers will always make mistakes, right? Because they're always going to make connections they shouldn't do. They're going to do stuff that were not supposed to be done, i.e. they're going to do bad stuff. The question is, do you know what that looks like? And the more you know what good looks like, the easier it is to identify, what non-good or bad or malicious actually looks like. And this takes me, for example, to something like a firewall rule, right? So if you look at firewall rules, firewall rules are a good example of things that are very hard to maintain, sometimes to visualize, and it's very easy to make lots of mistakes on it, right? But you could argue that there's a whole set of patterns that you want to apply. There's a whole set of things that you can do. So imagine this flow that, for like even something as simple as a security group in AWS, where as your deployment starts to go to the pipeline, you rewrite those AWS rules or those AWS mappings into, for example, a set of safe states. So, for example, you don't allow certain ports, you don't allow SSH, or you make sure that SSH is configured in a certain way. You don't allow port 80, you only allow 443. So you can almost like rewrite that particular a rule or that particular CloudFormation or Terraform script, right, into a safe state. And I really, really like that because it gives us a lot of scalability. And of course, we're going to have to make sure it works in the real world, make sure that there's flexibility into how some of those things are done, but it will do a huge amount of work to nudge and to force good practices and to make sure that insecure defaults or insecure setups never reach production. So I really, really like this model. And again, if you can really map out what good looks like, for example, in your network traffic, in your firewall rules, etc., you can then feed that to your SIMs, you feed that to your other monitoring and detection tools, and allows them to much better benchmark, even do machine learning and other stuff with it, where they can actually detect much better outliers for those things. Now, config files is a variation of this, right? So now we talk about Terraform scripts. We're talking about secure configs, right? We talk about secure defaults. I always find that the hardest part in security sometimes is making sure that the entity making the change, a DevOps engineer, developer, business analyst, somebody using the UI, whatever, they understand the side effects of what they do. So sometimes, some tools and vendors or open source technology are very good at saying, here's a secure default, right? Ideally that's what they have, right? It comes out of the box in a default good state, but it's very easy to start to make it insanely secure. So again, I like this idea that we can start to rewrite against some configs based on some of the threat profiles, where we can say, for this application, there's only certain variables you can touch, right? This is the default setup. So this is, where we're going to read those particular configurations. So we make sure that it's a very acknowledged decision to change the behavior or some of the things. So I really like this idea of, again, rewriting config files so that even if somebody, using a framework or is not fully aware of it or doing a bit of a rush thing or doesn't fully understand why certain things should be there, even if that's what gets checked into the code originally, the safe version is what ends up in the code base. And of course, that I actually think that what we want to do here is not show a demo in a bit, is we probably might even want to show a demo or even change the user's UI or give them feedback to say, hey, you just did this, but this is actually what's being changed, right? So I think, again, there's a lot of research that needs to happen at that level. And this takes us to source code, right? Like a good example of this done correctly is the new generation of dependency checkers that actually submit pull requests. But we need to take it to the next level, right? We need to start, sometimes, modifying the code, because sometimes the frameworks and the languages are far too powerful for their own good, right? So I really like this idea of having certain modes where it doesn't matter if you wrote an insecure function, the code would actually be rewritten into the secure way, right? And I think we now got technology that can allow us to do this. And there's a lot of thinking about this automatic patch generation, some automatic patching stuff. And I want to show you, two good examples of how this could work. So this is something I created, in 2013 or something, right? But this shows, for example, a developer UI that as it codes, is kind of compiling, and this is the O2 platform, which I'm going to show later today. But this is basically, you could see that, it's kind of connecting, compiling it. And then what's going to happen here is going to show you an example of when you connect the dots, You could see, so this is C#. It means that this request.name comes directly from the query string. So this value is tainted, that value is tainted. So now when you click here, right, well, you could see that at the moment it's good because this is a static variable, but as soon as you connect the dots, you get a cross-site scripting, right? So this is what I was saying, that, we basically, for example, like, we shouldn't allow this to happen unless it's really, really what you want to do, and you almost want to rewrite the code into a known good state. And then, the other examples here is that if you then, create one that you got, SQL connections, you can see that, here, when you connect the dots and you get user details, goes the name, there's the place where string concatenation is happening, and then there's the command that actually executes it. So you get the vulnerability from source to sink in this case, right? And there's a bunch of other examples in this video that you guys can see later. But the one I think is very interesting is actually this one. So if you look at this is an example of literally auto-patching the code. So if you look here, this is the UI of the user. So I'm actually using ASTs, abstract syntax trees, and refactoring to basically transform response.write, which is vulnerable, right? You can see here, there's the request, gets the request grabs the payload variable, which is sent over here, which basically means that, if you look at this, well, the problem, the vulnerability here is that, you got, the HTTP request comes from the outside world. The request payload is the payload in the query string payload equals something. So you can see that there's no validation going on here. That is passed into this variable, which is then written directly to the outside world, to the browser. So this is like the cleanest, cross-site scripting that you can get, right? But what we're going to see here is that you're going to see that as you type, right, on the right, what you then have is, look, if you look there, right? So if you go response.end, there's no auto encode, so you get response.end here. But if you go response.write, immediately, if you look at the generated code, you already has the anti-XSS HTML encode, which is important because that's the one you should be using in this particular case. So you could see that as you type some text, it does immediately that. Now you could even combine this with the previous one and say, actually, in this case, I don't need this because, it's still safe. But as soon as I add, for example, the payload, right? Like this, for example, you can see request or exploit me. You can see that the response.write, anti-XSS, HTML encode, request or exploit me. So basically you have unsafe on the left and safe on the right. So what you have here in a way is again, a really cool example of rewriting into known goods from, in a way, unsafe to safe. So you go from this code is exploitable, and then, the same line of code on the other side is now safe. Any questions or comments? All right. But I think this is really cool, right? But it introduces a huge amount of questions, right? And it's not going to be easy to get there. But I feel that, this is where we also will start to make a huge amount of strides. And this is also where we're going to scale, because the knowledge of what you can do, sometimes, again, the frameworks try to abstract and make that easy, but is usually still not, fully understood. So either the entity writing the code or making the connection doesn't fully understand the side effects of what they're doing, especially as you go into more complex applications and more complex systems that you have to map. In fact, the Glamorous Toolkit, it's again, a cool application that allows you to go on this path to deliver this. So one interesting question here is, we want to start with simple cases, right? We want to start just refactoring this. And the other big element here, which I haven't actually touched a lot, but it's also like, how do you prove that you went to a good state? And I feel that as the industry matures, as we mature our understanding of what good looks like, one of the areas that I think is still very immature is this idea that okay, how do you prove it's good? How do you prove that, for example, the behavior or the intended behavior or the intended look and feel or the intended, structure, etc., still survived on the rewritten? Because that's what will give us confidence. That's what will give us confidence to start to allow some of these things to happen automatically and some of this code to be written programmatically based on a set of rules. Which is why one of the first things you can start to do is enforce allow lists, enforce very explicit list of known good stuff, which actually, again, if you look at some of the send grep sessions that we had before, some of the very successful static analysis tools, they do that very well. They say, hey, this is what you should allow. Let's make sure that this is what's there. And sometimes, okay, you can also do the disallow stuff. This is the deny things. I don't want to see this here in there. But I much prefer the known good model. Like it's almost like you look at the framework or the language and say, these are only the functions that I want to see in the code. So although you have a library with this, I only want to see that. And there's been spectacular successes, right? How many buffer overflows got prevented by changing the use of string copy, right? str copy into the safer alternative. So there's lots of great examples. Parameterized queries replacing concatenated strings, right? There's lots of great examples of how to do that, right? Now, there's also a very interesting question of liability and insurance of modifying source code, right? Because if something goes wrong, who's now liable, right? Is the developer who wrote something that got interpreted by a particular interpreter who now modified and made it exploitable? Because some of these things, and I've seen cases like this where you try to fix a vulnerability over here, you end up creating a vulnerability over there, right? Or you fix something there and you cause a huge amount of side effects. And that's why part of this, I believe, will come after we understand what known good looks like. Because once you understand, for example, API level or network traffic level or business level, what good looks like in those applications, it's much easier to refactor it, to say, well, look, as long as the inputs and the outputs and the test cases and the test suites that we have are the same, then I can make changes in those environments. In fact, the session we had yesterday about the new AI and ML regulation in Europe actually talks about providing data sets, talks about providing representative test data, which actually I think most apps had to do the same thing. They will struggle, right? So again, this might force raising the bar of how we develop a lot of these things. Now, the other one that I found very interesting is network protocols. Like, can we rewrite network protocols into a known good state? And also, this is where performance becomes super important, right? Like, can you operate at a speed where actually you're cleaning up a lot of your network protocols? You're cleaning up a lot of the mess that sometimes exists there. And a really good example of this is the net logon vulnerability, right? So if you remember from last year, there was the zero logon attack that actually allowed you to really compromise this. And what's interesting is that a lot of the defense and the ways were about, can you detect the typical exploits that happens? Can you figure out the pattern? But actually, when you look at this, right, and you look at actually the solution, the solution here, and the exploit is basically, sorry, just going back, the solution is if you send a large number of messages where a bunch of fields are filled with zero, they can change, eventually the domain controller password, right? The point here is that there's a very clear pattern that if we have the technology to rewrite the packet into a known good state, that vulnerability will be impossible because, that use case doesn't happen on normal net logon messages. So I think, again, like this allows us to really start to lock down a lot of the environments that once we can do this at speed, there's a lot of potential to really clean up a lot of our, massive, so sometimes pile of security vulnerabilities, or be able to protect all the systems because we make sure that the data that arrives at them is actually in a safe state. A good example is that there's lots of places where you can't patch easily. It's very complex to do. It's not even possible, or it's crazy expensive to do it. But you have to make sure those machines are still operating business critical functionality. So you could basically put something in front that makes sure that the only traffic or the files or configurations or whatever arrives at those vulnerable machines are actually valid. And then if you isolate them, then it doesn't matter if they have certain vulnerabilities because there's no way to trigger them. So I think, again, positive models have huge amount of potential, right, on this. And the final kind of set of examples here is like cloud services, right? Like at the moment, if you look at a lot of our cloud environments, like what does a good EC2 instance looks like? We now start to put rules where, if you start an EC2 instance that doesn't have some tags, doesn't have owner, doesn't have certain information, it gets deleted and destroyed very quickly, right? But that's just the beginning, right? Like I actually love this idea of when somebody writes a Terraform script or a CloudFormation, we actually, again, we rewrite it into our own current standard of an EC2 instance. And that means that there could be other things in there. There could be connections that we make sure the logs are correctly set up. Make sure, for example, the system management console is properly, system is actually enabled. There's a whole bunch of things that you can do, including Docker images, right? The same thing. We can actually start to say, at code level, as you create them or as you issue the commands, we make sure that only good commands or commands that match a certain level of functionality that we want to allow are actually in place. And of course, the other massive one is AWS Identity Access Management, right? Because it's so easy to create, for example, rules and keys and roles that have far too much permission than they should have. So we should have a mode where I could rewrite a lot of the permissions into this kind of known good state, which is, only have the permissions required for what you need to do or for the particular use case that you have there. And and that takes you to the sort of the data element, which is going to be even more interesting, although there's some already success stories, right? So spell checkers is basically rewriting data and information to a known good state. But you can take this to the next level where you can start to apply schemas to data structures. You can apply, all sorts of basically enforcements or rewriting it. It's kind of like sometimes there's one of the cool patterns you can do in code is you can sanitize data, right? So you could say, look, I am either going to, validate and block it, or actually I can sanitize it. So I know that I only support letters and numbers. So I'm only going to let letters and numbers go through, right? Now, sometimes that doesn't work, but it's a good way to do it. So, when you take structured data that you have, right, then you should be able to write rules for it. You should be able to, in a scalable way. And again, you need to visualize it. There's a huge amount of stuff to do here, but I feel also there's a huge amount of potential to make sure that the data is well formed as it travels the organization or as it's at rest. Even things like encryption and making sure the right things are encrypted, all those things get very complex very fast. If we have a distributed way to do this in a good meta language and a good set of patterns that we can apply, I think we can make a massive difference in the quality and the security of data, even just understanding where the data is, right? Which will make a massive difference in a lot of organizations. And then, you have unstructured data, which requires, a different kind of thinking, but there's also a lot of data that has structure, but you haven't figured it out. So I think you also need a lot of good toolkits that allow you to very quickly gain visibility to what's actually in front of you, right? And understanding. And if you look at today, the CDR pattern is actually one of the best ones at detecting a file type, because it doesn't look for magical things. It literally tries to, look at the structure of the file and start to say, is this file, structured like this? Does it meet these particular structures that we have, right? And if it does, I can very comfortably say that it's a PDF or a JPEG or a GIF, etc. But if you take a polyglot file, which is files that can be 2 or 3 files at the same time, it becomes very important to pick up the right one, right? Or at least to pick up one and make sure that only that one goes through. And then the final one is just machine learning, right? I actually think that most machine learning today is highly inefficient, and it's actually, it's basically solving the right problem the wrong way, right? It's almost like we don't have good structures. We don't understand, what good looks like. We don't understand sometimes good definitions of good structures. So we're going to basically almost brute force our way into an algorithm that, can do this stuff. Again, not everything in machine learning is like this, but I actually feel that, so this is my hypothesis, right? So hopefully a couple of years, we'll see how it goes. Now, my hypothesis is that the more clean data you can feed a machine learning environment, the easier it will be to understand the reasoning behind the decisions, and the easier it will be to detect outliers, right? In fact, you might have a situation where you have to protect the data that goes into a particular machine learning algorithm, because it probably could be very susceptible to all sorts of variations of data sets, especially one that it's wide, or is a wild sort of variation of the original data set that was used to train the algorithm. So I feel that there's a lot of power here to improve dramatically the quality and the discoverability and the understandability and how I actually operates of machine learning algorithms. But also, I think that as the data grows, again, machine learning algorithms are going to be super powerful, and eventually maybe AI, but at least ML, to understand what good looks like, so we can create the patterns that then reinforce at a wider level. And that's kind of it. That's sort of my brain dump on, open, sort of positive security models and going into a known good state. Any questions, or we just wrap it up? Okay.
I don't think there's any questions, so I think we're good to wrap up.
All right. So thanks. And I really would like to have some debates on this. So maybe somebody can see this, and then let's continue in maybe next month or the month after, right? To start to explore some of these areas where maybe in a short time we can start to look at rebuilding into a known good state. So I think you can stop the recording.
Okay.